then you can generate logic function. So decoder basically works a logic function. So एग्जाम में ऐसे क्वेश्चन ज्यादा नहीं बनते हैं क्योंकि इसमें छोटे छोटे क्वेश्चन बनते नहीं, मेनली डिजाइन के क्वेश्चन रहते हैं. That is not this type of question is not asked in the exam. Okay, but just I have given you the introduction. So let us calculate, do the next topic, which is very important for exam. That is your sequential circuit. Okay, so we have digital circuits. Okay, now digital circuits can be classified in two ways. One is called your combinational circuits. Combinational circuits, what we are doing so far, okay, like your arithmetic circuits, okay, full adder, subtractor, okay, comparator. Then we have done multiplexer. Then we have done this your encoder, decoder, encoder, decoder. So these all circuits are the example of combinational circuit. Okay, combinational matlab we, in order to perform this circuit we need combination of logic gates. Okay, but these kind of circuit do not have a memory. So these do not have a memory. Okay, these kind of circuits do not have memory. Okay, so you have a combinational circuit or combinatorial circuit. So your combinational circuit. Okay, you're applying input and you're getting output. So your output basically depends on the input. Okay, जो भी आप input दोगे, you accordingly these kind of circuit will give you output. Okay, like how about the full adder. So that kind of circuit, okay, output depends on this is your combinational circuit. Combinational depends on present state of inputs. Okay, now sequential circuits, second part is sequential circuits. Okay, now what are the difference between sequential circuit? So in sequential circuit you have memory. Okay, you have memory elements. So example of sequential circuits are your shift register, counters, which we are going to do now. Okay, so these are the example of sequential circuit. Okay, all these circuit involve some memory element. Okay, it is called flip-flop. Memory element is flip-flop. So in sequential circuit you have output, some part of output also coming as a feedback. Okay, some part of output also coming as a feedback into the input. Okay, so you have a memory element. So this is your memory element. Okay, and this is the example of sequential circuit. So in combination circuit, output depends only on the present state of input, but in sequential circuit, okay, are those circuit. So sequential circuits are those sequential circuit are those circuits in which, okay, output not only depends not only depends on present state of input, as well as prior input states, okay. What does it mean? Because now this circuit is a memory, okay. So in combination you apply input, you're getting output, okay. It's not a memory. Now this is a memory which is going as a feedback to the input, okay. Now whenever you're giving input, your output depends not only on this input but also this output which was earlier present, and this earlier output was present due to the earlier inputs, okay. So now this matters, this present input as well as prior input is also matters, okay, because that is affecting our present state. So that kind of circuits are called your sequential circuit. So simple definition: circuits which have a memory element, okay, are sequential circuit. Combination circuit do not have a memory, okay. Now sequential circuits again can be classified, okay. If I write sequential circuits, these can be classified as a synchronous circuits and asynchronous circuit. Okay. Now again, synchronous circuits are the circuits which are controlled by a clock, okay. Asynchronous circuits are which are not controlled by a clock. That is, non-clocked sequential circuits are called asynchronous. So not controlled by a clock signal or clock, simply clock or clock signal. Okay. Now what do you mean by clock? Clock is just a continuous narrow pulses of signal, okay. This is your narrow pulses, this makes your clock, okay. This is your clock. We'll talk about this clock again. So this is the classification, okay. Now what we are going to do in this part, okay, we are going to discuss one thing, flip-flop latches, flip-flop counter and registers, okay. So the first thing is so what is our syllabus, okay. So I'm going to discuss first latches and flip-flops. Both are same, okay. Latches and flip-flop both are same. Latches is basically non-clocked flip-flop, non-clocked, that is asynchronous. Non-clocked flip-flops are called your latches, okay. So once we finish latches, okay, and non-clocked flip-flop, then we will go to the gated latches, okay, and then we'll see 4 type of flip-flops. Basically your SR flip-flop, which is clocked, okay. So this is non-clocked first latches, okay, and then we'll go to gated latches, then we'll come to flip-flop, okay. So we'll see SR flip-flop, okay. Then you have D flip-flop, T flip-flop, and then you have a JK flip-flop. Okay. So once you complete this one, then our base for register and counter will be developed, and then we'll do counter. And after this, we'll do registers, shift registers, because these all require flip-flop. Register is a memory element, okay, which is cascade of flip-flops. Similarly, your counter is a basically cascade of flip-flops. So first we need to understand what is flip-flop, okay. Then we'll go for shift register, and then we'll do counters. Okay. So let me start with now latches. So what is latch? Okay. So latches. Okay. So I'm going to discuss NOR gate SR latch, NOR gate SR latch. SR means SR the input variables. Okay, two inputs are there, and NAND gate SR latch. NAND gate SR latch. Okay, so now let me first discuss what is basically latch or flip flop. Okay, both are same. So let me discuss what is flip flop. Okay, so flip flop. So you are applying. This is your flip flop. You're applying some input to flip flop. Inputs. Okay, and it has a two output. Q bar. Okay, so you can have many inputs, but you have two outputs. Okay, and Q refers the state of flip flop. Q refers the state of flip flop. Okay, so obviously when Q is 0, then you can have output can have a 0 or 1, anything. Okay, once it is 0 it is 1, this is 1, this is 0. Okay, so we don't bother about this one. We define the state of flip flop by Q. Okay, Q will tell what is the state of flip flop. Okay, so if Q is 0, okay, flip flop is in reset state. Flip flop is in, or flip flop is called in reset state. Okay, in reset state. Okay, and if your Q is equal to 1, okay, flip flop is called in set state. Okay, so flip flop has two state: reset state, set state. Q0, that means it is a reset state. Q is equal to 1, is set state. Okay, both Q and Q0 cannot be equal. Q and Q bar cannot be equal. If they become equal, that is called invalid state. Invalid if they have become equal. Okay, that is called invalid state or indeterminate state. Indeterminate state. Okay.
सर ये इनपुट में क्या सिंबल दे रखा है आपने?
बस
वो स्क्रीन दिखाई,
खाली इनपुट लिख दो, बस इनपुट लिख दो, इनपुट्स लिख दो.
ओके सर.
Now, in order to understand working of flip flop, okay, so flip flops are generally made of NOR gate or NAND gate. Okay, so we will be using NAND gates mostly to design your flip flops. Okay, so first we start with NOR gate. So what is your NOR gate basically? Okay, so your NOR gate is like this. If you're giving some input, two inputs, you're getting output which is noted or plus noted. Okay, so whenever if you whenever this one input is 1, Okay, if NOR gate, if one input is 1, so automatically output becomes zeros, isn't it? So this, the value of this input doesn't make any sense. Okay, suppose if you have a 0, then also 1 plus 1 is 1, and your output is noted, okay, 1, and you get 0. Okay, even though if you do this variable is 0, this other input is 0, then also means 1, and then this, and your output is 0. Okay, so whenever this is one input is become 1 in the NOR gate, other has irrelevant, other variable, other input is irrelevant. Okay, either you give 0 or 1. Okay, the state will not change. Are you getting my point? This point, if you have, if your one input is 1 here in NOR gate, other input become irrelevant. Okay, this will not change the state of your change, it will not change the state even though you put anything. If you put 0 or 1, the state will be same. Now let me make what is your SR latch. Okay, made of, similarly in NAND gate. Okay, so we'll discuss NAND gate also. Similarly in NAND gate, okay, your output Y is basically your A B bar. Okay, so if I'm giving some input, say one input is 0, so automatically this will make whole 0, and your output will become 1. Okay, now here whether you're putting 0 or you're putting 1, okay, that doesn't make any sense. Okay, so that point you have to remember. Okay, NAND gate, 1 is 0, other become relevant. NOR gate, if is 1 is 1, other become irrelevant. Okay, similarly here if is 1, okay, then also it become irrelevant. Now this will decide, if this will be 1, then what will come? 0. And if it is 0, and then what will come? So basically this is, if this is 0, this become fixed. Okay, with this 0, whatever here, this becomes fixed. Okay, so this has become irrelevant. Now let me make a NOR gate SR latch. NOR gate SR latch. Okay. So you have two NOR gates. Okay. One output, one is input, is others output. So this is similarly this for this one. They are connected like this, and you have one more two inputs. Say this is R and this is S. Okay, so this is your Q and this is your Q bar. Okay, now let me make a table for this one. So you have two variables R and S. So you have R, S, R. So they can have a combination either 0, 0, 1, 1, 0, 1, 0, 1. Okay, and I'm writing the output by Qn. Okay, so this is my present state. This is my present state, and once I apply the inputs, what will be my next state? Okay, Qn plus 1, that is called my next state. Okay, now for example, now suppose if I'm giving R0, suppose in the beginning my Q is 0. Okay, if my Q is 0, then what will happen? Okay, so everywhere I have to make two states. Okay, this is 0, 0. So 0, 0, and this is 1. Okay, similarly I have to make two cases. Okay, present state can be either 0, either can be 1. Okay, accordingly I have to make the tables. Okay, now next state is what? 0, 0, then again 0, 0, 0, 0. So it can be 0, it can be 1, and now just 1 minute, 0, 0, 0, 1. Okay, 0, 1, 0, 1, it can be 0, it can be 1, and then you have a 1, 0, 1, 0, it can be 0, it can be 1, and then you have at the last you have 1, 1, 1, 1, it can be 0, it can be 1. Okay, now we have to see how this circuit works. Okay. Now, what is the state? Okay. So I'm applying 0, 0 here. This is 0, this is 0. And the present state is 0. So this is 0, this is 1. Okay. This q bar is 1. This q bar is 1. And this is your 0. So what will be my next state? So this, so say you are 0, 0 going here, this becomes 0, 0, 0, 0, again become 1. This is 1. This is 1 going here, 1, 0, 1, 0, 1, 1, and this become NOR, this becomes 0. This 0 going here, this is stable. Okay. So when you are giving 0, 0, if present state is 0, your
Sir.
next state is also 0, isn't it?
Sir, can you repeat, sir? This I didn't understand.
So your present state is 0. So Q is 0. So Q1 bar will be 1. In Q bar is inverted output. Okay. Now you are giving R0 S0. Okay. Now whether you see the output will change or not. We want to see if I give 0, 0, whether the output will change or not. Okay. So now here we have a 0. Okay. See, this is initially, this is a memory element. Okay. Some value is there. Now you're changing the variables. So if you give 0 here and here already 1 is there, output connected here, this is 1 plus 0, this become 1 plus 0, 1. And if you put NOR, okay, 1 bar, this becomes 0. So it is 0 here. Again, 0 is going here. Okay. And this 0, 0, 0 plus 0 bar, again 1 is coming out. This 1 is going here. So there is a, so this output is not changing. So if your input is 0, okay, if your Q, if the state of the flip latches is 0, it the next state also remains 0. So 0, 0 not changing the state. Okay, it becomes, this is remains 0. Now suppose if the initial state is 1, the initial state is 1, this is 0. Okay, now you're giving 0, 0. So what happens? Okay, this 1 is going here, this 0 here, 1 plus 0, 1, and the bar has to be done 0. So you have 0 here, this 0 going here, this 0 going here, 0, 0, you coming 1 here, 1 going again here. So again, there is a no change. Okay, if you are giving 0, it remains 0. If it is 1, it remain 1. Okay, that means the state of the flip flop, this 0, 0 variable, okay, both are low values. They are not changing the state of the flip flop. So that means this kind of variable, this kind of situation is called no change state. This is called no change state.
Sir, after Qn you have written Qn plus 1.
Qn plus 1. Next state. Okay. So the state is not changing. Okay. Now let us put 0, 1. So say initially this is your 0, this is your 1. Now you're applying S0 R1. Okay. So this is initial state. Here you have a 0, here you have a 1. Now you're putting S0 R1. Okay, or R is where? R is there. R is there. Say R is here. R is here and S is 0. So now you're putting what? 0, 1, R1, S0. Okay. Now tell me whether state will change or not. Now you have this 1, 1. Okay. So 1, 1 will give you 1 again. Okay. And this 1, 1 becomes 0. 0 going here, this 0, 0 become 1 again, 1 coming here. So if this is 0, it also again remains 0. Okay. If it is a 0, 0, 1, then 0 remains 0. Okay. Now I'm taking next case, I am making it 1. I am making it 0. Okay. This is R, this is S. Okay. Now the initial state here is 1. And this state going here 0. Okay. Now I'm giving you 1, 0. That is 0, 1, 0, 1. Okay. Now what will become? 1 plus 0, 1. Okay. And the bar will be 0. So this becomes 0. And this 0 goes here. 0, 0. This becomes 1. Okay. And this ones go again here. So once the OR gate 1 is there, other will not affect. So 1 plus 1. Again you 0. Again you go say 0, 0, you 1. That becomes stabilized. Okay. So if the state is 0, it remains in the 0. If the state is 1, it becomes the state becomes changes to 0. Okay, so when you're applying 0 variable, whether it is a state 0 or whether state is 0, the next state is 0 0. That means that is called your reset state. Are you getting this one? I told you there is a two state, set state and reset state. Okay, now when you're getting both 0 0, okay, that is called reset state. Flip flop is reset state. Okay, now say if I'm applying 1 0 here, okay, 1 0 means S is 1, R is 0. Okay, so let us start from the first thing, this 0. So this is 0 and this is 1 here. Now I'm applying here 0, I'm applying high input here 1. So what happens now? Okay, this 1 0 becomes 0, 1 plus 1, and this becomes 0 here. This 0 goes here, 0 goes here. Again, what happens? 0 plus 1 1, this comes 0. Okay, this 0 goes here, 0, this becomes 0 0, and 0 becomes 1, and now this 1 goes here, again back 1 1 1 0. Now this becomes stable. Okay, so now whenever you have this 1 0 variables, okay, so what happens if you have a 0, it will become 2 1. Okay, now you can start again from 1. In the beginning you have 1. Okay, are you getting what I'm doing here? समझ में आ रहा है कि नहीं आ रहा, क्या कर रहा हूँ परमप्रीत?
Yes. Yes,
Okay.
sir.
सर
हाँ,
समझ रहा है।
so अभी देखो ये 1 है, अब next present state is 1. Okay, so this will be 0, obviously this is 0. Now you're applying 1 0. Okay, now what happens? 0 0 0, this become 1 here, then this 1 1 become 1, this becomes 0 here, this 0 is go here, 0 0 1 here, so this becomes stable. So even though if it is 1, it remain in the 1. Okay, so this is, so now you both the states are 1 1, and this is called your set state. This is called your set state. Okay, so when you have a variable 0 0 0 0 are ineffective. 0 0 cannot change the state. Okay, that is called no change state. 0 1, when you're making 0 1, it is making reset state. If you're giving 1 0, it is making set state. That means these variables are capable of changing the state of the latch, okay, of flip flop. That's why it is called active high SR latch. Okay, this is called your active high SR latch. Okay, why this is called active high SR latch? Until the one input is not high, the state will not change. Either you make 0 high, R high, or S high. One variable you to make high, then only the state will change. That's why it's called active high SR latch. Okay, now what happens if you have 1 1? Okay, now what happens if you have 1 1? Say I'm applying 1 1. Say initially it is 0. Initially it is 0, and this is your 1, and now I'm applying 1 1 here. 1 1. So this 1 is going here. Here you 0, so it's going 0 here. Okay. Now what happens? Okay, see, when I apply 1 1, this become 1 plus 1. Opposite 0 will come here. It becomes 0 here. This 0 is here. 1 plus 0. What happens here? 1, and that again goes to 0. This 0 goes here. Okay, 0 plus 1 1 0 is it remains 0. Similarly, because once this is fixed, the output, this input cannot change anything. This also becomes same. So now both become same. Okay, whenever you apply 1 1, okay, so your both becomes same. So that's why this is called your invalid state. Okay, this is called your invalid state. So Q is equal to 0, reset state. Q is equal to 1, set state. If this both are become equal, that cannot happen, because one is Q, other is Q bar. One is in output, other is the input output. Both cannot be same. Okay, so that is called your invalid state. Okay, that is your truth table for your NOR gate is NOR gate SR latch. Okay, this is NOR gate. हाँ
सर जो वो एक्टिव हाई एसआर लैच कहा था कि until one input will
हाँ
not be high.
भी देखो, अगर हम 0 0 कर रहे हैं तो स्टेट चेंज नहीं हो रहा है, दोनों में से एक को हाई कर दिया तो स्टेट
Yes,
चेंज हो
sir.
गया, एक को हाई कर दिया तो मतलब जब एक एक्टिव होगा एक हाई होगा, ओके, तभी वो लेच की तरह काम करेगा। ओके, दैट्स व्हाई इसका नाम है एक्टिव हाई एसआर लेच।
Okay, sir.
Okay, now similarly you can make latch also using NAND gate. Okay, so put now NAND gate SR latch. NAND gate SR latch. NAND gate SR latch. Okay, so now you have two NAND gates. Okay. So output of one is going to other, output of this is going here. So this is your Q, this is your Q bar. Okay, here I'm putting my input, say this is my S, say this is my R. Okay, now let us see what happens for NAND gate and SR latch. So now you have SR, okay, and your present state, you have a next state, now you have a state, okay, state. So when you have a 0 0, this can have a 0, this can have a 1.
सर
हाँ
सर जो क्यू एन हम 0 1 लिख रहे हैं मतलब
हाँ
0 and 1 ये क्यू और क्यू बार की है ना फिर?
नहीं, क्यू बार का है, मैं खाली इस क्यू बार को मैं लिख ही रहा हूँ। The state of the flip flop, I told in the beginning very clearly, state of the flip flop is mentioned by your out only Q with Q. Q तो inverted output है जिसका opposite हमेशा होगा। Okay,
Okay.
state will be always defined by Q. तो Q initially can be 0 और 1, कुछ भी हो सकता है ना, भी मेमोरी है, भी कोई किसने लेबोरेटरी में फ्लिप फ्लॉप यूज किया और छोड़ के चला गया। ओके, और उसमें आखिरी आउटपुट 1 है कि 0 हमको पता नहीं है, अब हम आके नया इनपुट लगा रहे हैं। ओके, तो क्या हो रहा है, हम so we are taking all the possibilities. Okay, now it is your 0 because it's a memory, it will keep the memory always.
Yes, sir.
Okay,
Understood.
so now you have, say the next state is, say we put 0 0. Okay, now what I can take 0 1. Okay, 0 1, and this again can be 0 1. Okay, again I can take 1 0 1 0. Okay, this can be 0 or 1. I can take 1 1. Okay, and this is 1 1, so it can be 0, it can be 1. Okay, so this is my table. Okay, now it is see how does it work. Now I told you, once you give any element 0 in NAND gate, okay, other input become irrelevant. Okay, now say this is in the initial state, this is 0, and this Q is 0, and this is your 1. So 1 is going here and the 0 is coming here. Okay, now you are applying 0 0, you are giving 0 to this one, you are giving to 0 to this one. So what become this 1 0 0, this become a 1. Similarly here 0 0 0, this become 1, both become same. Okay, so that means this state, okay, 0 0 state, whether you put 1 0 is automatically become 1. Okay, so 0 0 state is basically your invalid state, both cannot be same. Okay. Now you take 0 1 as 0 R1. So before that you share as R. Now you say this is 0 and say this is 1, 0 going here, 1 going here. Now you give the input 0 1. So you give 0 here, you give 1 here. Okay, what happens again? This 0 1 0, opposite 1 will come. Okay, 1 will go here, this become 1 1, 0 will come here. Okay, this 0 goes here, 0 0 0, you get 1 here, 1 goes here, you get 1 1 0 here. Okay, so if it's 0, it become 1. Okay, so now you are applying 0 1. Okay, so if it is 0, it is becoming 1. Are you getting? If the initial state is 0, the next state is 1. This is stable state. You can check. Now nothing will change. 0 0 0 always 1, 1 1 always 0. So this is stable state. So now it's not changing. So earlier it was 0, now become 1. So this is, so 0 becomes, next state become 1. Okay. Now I start with 1. Okay. I start with 1. So this will be 0. This Q is 1, Q bar will be 0, 0, 1. Okay. And now I again apply 0 1. Okay, so 0 0 0. Okay, 0 dot 0 and 0, inverted 1. Okay, 1 goes here again, so 1 1 again, 1 1 becomes again 0. Okay, this becomes 0, 1 1 again, 1 1 0, 0 goes here, 1 here. Okay, and this is also fixed, 1 1 0. Okay, so again if it is 1, it also remains as 1. Okay, so sorry, here it remains 1. So this is basically what I'm writing here, 0 1. So this is basically yours called set state. So 0 1 0 1 in the NOR gate, 1 0 was the set state, 0 1 was the reset state. Here 0 1 is the set, 0 1 is the set state. Now 1 0 will be reset state. You can check. Okay. Now 1 0. So this is 1 and you're 0. Initially you're starting with 0. Initially starting with 1. This 1 is going here, and this 0 is going here. Okay, now 0 1 0, opposite comes 1. Okay, 1 goes here, 1 1 1, opposite comes 0. Okay, so 0 again goes here, this become 1 fixed, this become 0 fixed. Okay, so if you have a 1 0 0 0, again becomes 0. Okay, now let me say, now this is initially 1. So this will be initially 0. This is 0. Now what happens? Okay, 0 1 0. This remains 1. Okay, this ones go here. 1 1 1. This becomes 0. This 0 become here. This become 1. Okay, so if 1 is there, it remains 1. Okay, correct. If it is, so this is called no change. No. How will call no change state? This is no change state. Check it this one again. 1 0. Check it again. 1 0. So if it is 0 in the beginning, this is 1 in the beginning. So this 1 is beginning. Okay, so this 0 going here, this makes this 1, this 1 goes here, 1 0, you have to make this 0, make 0. So this 0 going here, 0 0 is 1 1 coming here, this 1 goes here, this 1 1 0 coming here, this so if you 0, you're getting 0. Okay, now let me put 1 1 0. So this 0, this is 1. Okay, now check 1 0, because this is 0 and this will not change, it will be kept 1. If 1 goes here, this becomes 0. Okay, now this 0 comes here, this will not change. Okay, since this is not changing, this will also not change. So if you, even though 1, it's become to 0. Okay, this is called your reset state. Reset state. Okay. Now both 1 1, both 1 1. This is also 1. This is also 1. Okay, so you can check. Tell me what will happen. Now you tell me what will happen. If you apply 1 1, what will happen?
सर ये सेकंड सेट स्टेट है ना?
सेकंड सेट स्टेट है. सेट स्टेट. बताओ लास्ट वाली क्या होगी, बताओ. बताओ क्या आएगा?
सर नो चेंज रहेगा।
Yes, sir.
लक्ष्मी, नंदना, तेज कुमार, क्या आएगा बताओ?
Sir, 0 1 ही आ रहा है.
No change.
0 1. Okay, so this is called no change state. Very good. So this is your no change state. Okay, so this is your latches. Okay, that is, they are not controlled. They are not controlled by clock, or they are not controlled by gate. Okay, so now onwards we'll use only this NAND gates. Okay, NOR gate we will not use. So now let me do one more. Now this was NAND gate SR latch. Okay, so put the heading gated SR latch. Gated SR latch. Okay, gated NAND gate SR. तो NAND gate में नहीं लिख रहा हूं, आपकी मैं जो भी यूज करूंगा NAND gate ही होगा. So check gated SR latch. Okay, gated SR latch. Now what is gated SR latch? Gated SR latch is like a not exactly clock, but it has some input which controls the controls the function of the latch. Okay, so what is the logic circuit for gated SR latch? Now onwards you have to make the table. I'll just make a circuit. Okay. So again we have AND gates here, like we are making simply the output of one will be input of others. Okay, here we have variables are coming. This is my Q, this is my Q bar. Okay, and this time what I'm doing, I am putting one more and NAND gate. Okay, NAND gate. So this is basically a latch, and this is called a steering gate. So बताऊंगा अभी क्या है. This is one, and this is coming here. Okay, and here you have S, you have R, and these two input is called enable. Okay, EN is enable. Okay, now enable can have only two values, 0 or 1. Okay, enable can have values 0 or 1. Okay, अगर मैं enable को 0 कर दूं तब क्या हो जाएगा, इसका आउटपुट क्या हो जाएगा? If enable is 0, what will the output of this gates?
1.
1. Okay, so once enable is 0, these inputs have no effect. Okay, whenever NAND gate one input is NAND gate is 0, other inputs have no effect. Okay, so that will be in that condition, this input become inactive. Okay, they have no effect. Okay, so when you enable, then only this input will work. Okay, so what I'm saying here, your latch will work. Latch will show flip-flop. Okay, the state of the latch will change only when your enable is enabled. It's the latter is called enabled. Okay, enabled means when this value is 1, then only this flip-flop action will happen. For 0, this input will become inactive. Okay, so let me now make a table for this particular thing. Okay, now we have enable. S.
So for NAND gate, if we are giving one input 0 and we will get the output, na?
Output will 1 1.
तो
ये कुछ भी ये ऐसा कुछ भी है, सबको ये 0 बना देगा ना, 0 सबको 0 बना देगा.
भी 0 ना?
हाँ?
Enable should be 0 for working of the flip flop.
No, it should be 1. भी अगर इसको 0 कर दिया, इसको 0 कर दिया तो ये 0 हो जाएगा, 0 हो जाएगा, इसका आउटपुट 1 आ जाएगा, इसका आउटपुट 1 आ जाएगा, तो आउटपुट फिक्स हो गया ना.
Yes sir, yes.
तो अभी ये इनपुट का मतलब क्या रह गया, इनएक्टिव हो गया ना ये. तो ये तो इसके लिए 0 0 में काम नहीं करेगा, ये 1 1 में काम करेगा. ओके, सो नाउ यू हैव SR, you have a QN, you have a QN plus 1, and you have now state. Okay, now I'm making enable first 1, two cases. I'm taking 0 0 0 0. This is 0, this is 1. Okay, again I'm making it 1 1. You have a 0 1 0 1. This is 0, this is 1. Okay, again I'm taking 1 1. This is your 1 0 1 0. This is 0, this is 1. Okay, and again I'm taking this enable 1 1. This time this 1, this time 1, this 1 1, and this is the state 0 or 1. So it can be 0 or 1. Okay, and the last I'm taking your this is your 0 0. Okay, so once you make 0 0, this become invalid. This will not function. Okay, this will not function because once you make 0, this become fixed. Okay, so we'll see now what happens. Okay, now you tell me what happens in the circuit. So first case I'm taking 0 0. Tell me what will come if you take 0 0. What will the state? If it's 0 0, what will the state? Enable 1 SR 0 0. Okay, so I'm taking now as this is 1, this is 0 0. So once I give this 0 0, automatically this become 1 1. Now these become this 1 fixed, this 1 become fixed. Okay, now suppose if this is 0 and this is 1, so 0 0 again becomes 0 and this become ones. If 1 goes here, 1 1 1, this becomes 0 0 goes to again here, this is 1 1 goes to here, again it is 0. Okay, so that is 0 0 remains 0. Okay, similarly tell me what happens if you put 1 here 0 here. Now what will happen? If I put 1 here and 0 here, now what will happen? Tell me.
Sir, changes to 0.
Changes 0 कैसे होगा?
Q changes to 0.
कैसे? 1 0 0 0 का कॉम्प्लीमेंट क्या आएगा? 1. फिर 1 1 जा रहा है 0 0 जा रहा है तो चेंज नहीं हो रहा है. Okay,
Yes, yes.
so 1 remains 1. Are you getting? When you are 0 0 remains 0, 1 remains 1. That is called no change state. No change. I told you if one becomes 0 in NAND gate, okay, then this others this input become infected. So that cannot change the state. Okay, now both become 0, so they cannot change the state. Okay, this is no change state. Okay, now tell me next state what happens. So initially it is 0, initially it is 1. Okay, now you're applying 0 1. So it's giving 1 here. So 1 1, this give you 1 and output will come 0 here. Okay, and here it is fixed. You are giving 0 and 0 1 0, this is fixed. So now these are fixed. Okay, so you're giving 1 here and you're giving 0 here, and now you change the input. So input is 0. So tell me what is this condition tells you.
So 0 0.
Very good. So that means this becomes 0 0. That is your reset state. Reset state. Okay, similarly now if you do for 1 0, okay, this will give you 1 1 set state. You can put the values. Okay, now this is important for us. Okay, now onwards you always remember for SR flip-flop, which is either gated or clocked. SR flip-flop, which is either gated or clocked. 1 0 will give you set state, 0 1 will give you reset state. Okay, what happening in latch, that is different. Latch में उल्टा हो रहा था. Okay, latch में 1 0 में set हो रहा था, NAND वाले में. Okay, NOR इसका behavior NOR की जैसा है. Whenever you put this one, this will behave like NOR gate. Okay, so now just you have to keep in always mind that will make your you can solve the questions a little bit quickly. Okay, so whenever you have a clocked SR latch or gated SR latch, 1 0 is the set state, 0 1 is the reset state. Okay, so 1 0 is the your set state. Now what is 1 1? 1 1 1 1, what will give 1 1? If you give 1 1, what will happen? This is also 1. This is also 1. This is 1. So automatically this become 1. This become 1. This becomes 0. This becomes 0. Okay. So this become 1. This become 1. Okay. So 1 1 1 1 1 0. Okay. 1 1 1. This comes 0 here. 1 1 1 0 comes here. This 0 goes here. This make everything 0. This make everything 0. So you out बाहर आता है 1 आता है 1 आता है. This is your invalid state. Okay. So this is your invalid state. This is your invalid state. Okay. And once this is 0 0, so this is 0. So this makes 0. Okay. This makes 0. यहाँ पे input क्या है मतलब नहीं है. Whenever you have this 0, इसका कोई this become inactive. So you 0 0, you always get 1 1. Okay. And 1 1 has a no effect on NAND gate. 1 1 has no effect on NAND gate. Okay. This become 1. Now whatever this will be there, suppose this is 0, so this automatically becomes 1. Okay, this 1 go here, this becomes 0. Okay, if it is 1 here, it will be kept 1, so that will be no change state. Okay, so this is your, if you have a 0 1, your Q1 will be 0 1. This is your no change state. This is your no change state.
सर समझ नहीं आया सर, ये
कौन सा वाला?
क्या है ये सर?
ये वाला, ये वाला.
यस
भी तुमने
हेलो सर, वॉइस कौन?
हेलो सर, वॉइस
अगर ये 0 है तो ये 0 नहीं होगा,
यस
और आउटपुट 1 आएगा.
यस सर,
आउटपुट 1 आ गया, तो ये 1 आ गया, तो ये भी 1 आ गया. ओके, अब तुम इसको 0 रख के देखो, तो 0 रखा है इसको, तो ये 0 0 ये 0 हो गया, और ये बाहर क्या आया 1, ये 1 इधर गया 1 1, ये 1 हो गया, बाहर क्या आया 0 आया. ठीक है, फिर ये 0 इधर गया, तो ये फिक्स 0 का 0 ही रहा. अगर मैं इसको 1 कर दूं, इसको 0 कर दूं, तब क्या होगा? ये 1 इधर आएगा, ये 1 1 1 हो जाएगा, ये 0 हो जाएगा. ओके, ये 0 इधर जाएगा, ये 0 हो जाएगा, तो ये 1 आ जाएगा, तो ये 1 अगेन इधर आएगा 1 1, तो फिक्स हो गया अगेन. तो 0 0 रहेगा, 1 1 रहेगा. दैट इज कॉल्ड योर नो चेंज स्टेट. ओके, सो अब सवाल कल करेंगे हम लोग. सो दिस इज वी आर डेवलपिंग. ओके, दिस once you do this flip flop, then we will be ready for your registers and counters, because they are made of this flip flops. एप्लीकेशन क्वेश्चंस उसी पे बनते जाता, काउंटर्स पे एंड रजिस्टर पे. ओके, सो कोई क्वेश्चन तो पूछो, अदरवाइज आई एम स्टॉपिंग हियर.
Sir, you have told that 1 0 is always set state and 0 1 is reset state.
Yes, in SR latch. Okay,
In all SR latch.
SR latch gated हो या clocked हो.
Okay, sir.
क्योंकि इसी से हम लोग बाद में, इसी से हम लोग डी फ्लिप फ्लॉप बनाएंगे, इसी से हम जेके फ्लिप फ्लॉप बनाएंगे. तो 1 0 हमेशा फिक्स रहेगा आपका. ठीक है, 1 0 विल बी योर सेट स्टेट. ओके, थैंक यू.
Thank you, sir.